That when vanadium 2 compounds are dissolved in water, the following equilibrium is established, and he's asking how would you what would alter the composition of the mixture in favor of V2 plus ions? So you want more V2 plus ions.
Yeah. Okay.
These ones over here. You want more of them. You want the equilibrium to go backwards. So which one is the correct option?
Okay.
What would the first one do?
If you add, I said, it'll make there be more OH ions to equal out the acid. So I can't use that one.
Okay.
I don't know what the second one does. For the third one, if you allow hydrogen to escape, then it will it'll try and put more to the on the left because it equal wait no, then it go to the right because they're trying to recover the one that's lost.
Okay. So it's
And
going to
if you
try
make
and
it
produce more H2, right?
yeah, and if you
What
make it
about
more if you make it more alkaline, then it's gonna it's going to try and reduce the amount of OH on the right by adding more on the left.
so that's the right one, right?
Yeah,
So what's B, by the way?
I don't know.
What's a precipitate?
Um,
Like he's adding a reagent that precipitates V3 plus ions.
we
Well,
gotta like get rid of them.
yeah, I mean, if you have a container, right?
Mhm.
Precipitate is a solid, right? Ionic precipitation, if you remember. Like
Yeah, yeah.
in a solution, you have V3 plus ions. You
Mhm.
might add some ion, which, for example, you might add OH ions, right? And
Mhm.
maybe this VOH3 they might combine to form an insoluble precipitate.
Okay. Oh, that thing to the bottom, right?
Yeah, and the amount of V3 plus ions in the solution would be lesser now.
Okay.
So
So
if
I'm trying to
V3,
add more people.
so it's going to go backwards, right?
Mhm.
I said now this question. You have a question, and it says that X and Y react to form Z,
Mhm.
and the equilibrium percentage of Z is provided. So which statement about this
Okay.
equilibrium reaction is correct? First thing, by just looking at this, can you tell me which is the forward exo or endo?
Okay. Um,
I mean, you have to look at the graph.
yeah, so if you make them more pressure, then it gets less equilibrium. They're going more to the left. So so um so basically it prefers less temperature. It prefers less pressure, right?
It prefers less pressure or more pressure.
Sorry, more pressure because it performs better under more pressure because it goes upwards after a while.
Yeah, it's. I mean, all the graphs are going upward,
Yeah,
so the percentage of Z actually keeps on increasing if you keep on increasing pressure, right?
yeah.
Which is obviously because if you increase pressure, where would the equilibrium shift?
Um, Towards the side which has less less gas.
Which is going to be Z, right?
Yeah.
Forward.
Mm,
So that's pretty obvious. But I'm saying I'm not talking about pressure. I'm not talking about gases. I'm talking about
okay.
which one is endothermic, which one is exothermic. Forward is in endo or exo.
Forward is endothermic.
And how did you figure that out?
Um, because you told me the funny goes forward is endothermic.
Nee, which one? What did I tell?
You told me when we run the board the forward is endothermic.
Nee, it's not always endothermic. It depends.
Oh, oh, it depends. Oh, okay.
I mean,
Um,
usually what happens is you're given delta
mm,
H,
yeah.
and the delta H has some value, right?
Mm,
So you're given delta H and it has a particular value. If it's negative, then that means the forward is exo.
mm. But how would you figure out delta H? It's just giving you a bunch of different values.
Nee,
Is it
you
is it the difference between biggest and the least?
nee, what are you saying?
Is delta H 100 kelvins or is it 400 kelvins? Oh, it's
I mean,
either way it's gonna be positive. Either way, wait.
delta H is fixed. It's the energy change of the reaction.
Okay,
It's the enthalpy change. That's fixed. Uh, it's not going to change with temperature. The thing
okay.
I'm talking about is whether like evaporation, like if you have a reaction where H2 liquid is changing into H2O gas.
Hmm.
So the delta H is fixed. You need a very specific amount of energy to change it into from liquid to gas, right?
Yeah, okay.
So that has nothing to do with temperature. It's a fixed value.
Okay. So
So what I'm saying is, how would you figure out whether it's endo or exo in this case? Like if liquid water is changing into gaseous water vapors, I know that's
mhm,
endo because
mhm,
I know the reaction, right?
mhm. See, as it gets cooler, it goes more towards the Z. So that means that the Z prefers being cooler, which means it goes to cooler as
This
the
is
equilibrium goes to the right, it gets cooler. Because if it goes towards Z, it gets cooler.
okay. I mean, what was the rule? First thing, the Shatter principle rule. If you decrease temperature, which reaction is favored?
Exothermic.
So the rule was exothermic is favored, right?
Mm,
So you're decreasing temperature, right?
mm,
And what happens to the amount of Z? It's increasing, right?
increases, yeah.
So that means if you decrease temperature, the forward is favored, right?
Yeah.
So the forward must be the exo reaction.
Okay.
So that's how you figure out that it's probably negative.
Okay.
Did you get this?
Yeah, okay.
So so by looking at the graph, at a lower temperature you get more Z. So that means more products. That
Okay.
means that's the exothermic reaction.
Okay.
So the reaction is exothermic in the forward direction. That's the correct option.
Okay.
Next part is the dissociation of dinitrogen tetroxide into nitrogen dioxide is represented by the equation below. If the temperature of an equilibrium mixture of the gases is increased at constant, he's increasing temperature.
Mm,
First thing,
okay.
where would the equilibrium shift,
To the right,
and why?
because it's positive.
So the forward is endo, right?
Yeah.
So endo is going to be favored, right? So
Mm.
that's so you think what would happen to the volume of the mixture? Would it increase or decrease, and why?
Um, volume would stay the same, won't it?
Look at the gas molecule, number of gas molecules. How many gas molecules do you have on the left?
Oh, you have one, and on the right you have two.
So on the right you have two, right?
Yeah.
So what happens to the quantity of gas?
It increases. So that means the volume will decrease. Oh, sorry, the volume will increase as well.
Because the volume will increase.
Mm.
So which option is the correct one?
A.
I mean,
Wait, what?
it can't be C and D.
Hmm.
It has to be A or B.
Yeah, and what's thermal expansion? It basically gets bigger due to heat.
Yeah. You heat something and the gas expands.
Okay, so because of that as well. B.
So it's going to be B because you're obviously heating the gas, you're increasing temperature, right?
Yeah.
So it's increased. So there's going to be thermal expansion as well.
Okay, so whenever you heat anything, there's thermal expansion.
Whenever you heat gases, like a solid doesn't really expand thermally. I
Okay,
mean, it actually does,
but very, very tiny amount.
very little amount. I mean, gases, they do expand a lot.
Okay.
Okay, this one. So you're saying they're saying that there's the two gas bulbs R and S, and
Okay.
there's a mercury manometer, and
Mm,
it's held in a thermostat, which I think means I don't know what that means. The volume of R is twice that of S. R contains gas X.
mm,
And when the temperature is increased, so he's increasing the temperature of the entire thing.
Mm.
Which gases in bulb R would cause the mercury level in the right hand limb of the manometer to rise? So the right hand limb, the mercury level starts to rise. What does that mean? What does that indicate?
Um, that shows how less nitrogen, or how there's more X.
Yeah, this basically it indicates that there might be too much X getting produced, right?
Yeah,
And it might be exerting a lot of pressure, right?
yeah.
So maybe the amount of X increased.
Mm.
So 1, 2, 3. Which options are correct?
Well, it can't be free. And
What about
uh,
one? If you increase temperature, what would happen?
then more gas will be formed, but it'll prefer endothermic.
So it's going to go forward, right? Because it's positive,
Mm,
it's endothermic, right?
mm,
So if it's going to go forward, it's and more gas is going to be formed.
mm.
So is that a correct option?
Yeah, because more gas is formed.
Okay, that's fine. What about two?
No, because less gas will be formed because the equilibrium will shift to the left.
But why would it? Why would there be less gas formed?
So it's an exothermic reaction.
Okay, so it's going to go to the left. My question is, why
Mm.
is less gas formed?
Uh, oh no, see, they stay the same because the two same amount of moles on either side.
Okay, so it stays the same. So basically,
Mm.
the manometer would not change its level.
What is the manometer?
Probably this thing, like the
Okay.
mercury.
Oh, the mercury in the middle is called the manometer.
Yeah,
Okay, and why can't the nitrogen get less?
over here.
Yeah,
Like why would it get less if you're increasing temperature?
oh, yeah, good point.
I mean, like you're not physically removing the gas, right? And it's not changing
Yeah,
into anything. There is no
okay,
equilibrium.
okay,
So next is this one. W-
okay,
You're adding a catalyst, vanadium pentoxide. That's you're adding a catalyst to this equilibrium.
okay.
What does a catalyst do to an equilibrium?
It speeds it up.
So is the first statement correct?
Yeah,
Okay. What if they had said that the it speeds up the backward reaction? Would it still be correct?
yeah,
Okay. Basically, it speeds up all forward and backward reaction. So let's leave
yeah.
it. The next one is there's this Haber process. It's N2, and there is H2, and it's in equilibrium with 2NH3,
Okay.
and they're all gases. And the delta H, the forward reaction is exothermic. So out of these four graphs, which graph is the correct one?
Um, okay. If there's more pressure, wait, what? I'm not sure.
If you increase pressure, what happens to the amount of ammonia?
It decreased because there's less space for it to be formed in.
Anyway, with the equilibrium shift, if you increase pressure,
So if you increase the pressure, it'll go to the side which has less moles,
which is
Na2 and Na3, the right hand side,
so that means the amount of ammonia would increase.
increase.
So the graph should go upwards, right? The amount of ammonia would.
Yeah.
So these two
Yes.
graphs are fine. These two are incorrect, right?
Okay. Yeah.
So it's either A or B.
Mhm.
Now focus on temperature. Would the lower temperature graph be the higher one or the lower one?
Um. So if it has a negative, if it's overall negative, that means it's exothermic. So then it'll go to the left. So the equilibrium will shift to the left, but that doesn't have anything to do with
Yeah, I'm just saying, would you get more NH3 at 400 or 500?
it. I'm not sure.
I mean, like, see, this is the lower temperature, right?
Yeah.
And this is the higher temperature, right?
Mm. I think it'll be, but I'm not sure why.
If delta H is negative,
Mm.
like the forward is negative, right?
Yeah. So that means that there'll be less formula and the less temperature.
If you lower the temperature, which reaction is favored?
Uh. Oh. If you lower the temperature, then the exothermic reaction is favored.
Which is you get more ammonia, right, at lower temperature.
Okay. Yeah.
So that's why it's going to be A.
Okay. Cause yeah. Yeah. Cause it's okay. Yeah. Nice sense.
So the lower temperature graph would actually be having more ammonia. It's going to be higher.
Okay. Okay.
ठीक है? Is this clear?
Yes.
Next is what could contribute most to the increasing the equilibrium yield of ammonia? You want more ammonia.
Uh. Well, if you add a catalyst, and that'll make it go quicker.
What catalyst increase the yield of ammonia?
Mm, no, it will not. It'll just increase the rate of reaction.
Both reactions, forward and backward,
Yeah.
simultaneously.
Mm. Okay. So if you increase the pressure, then it'll favor the side with which has less moles, so that will increase it. Because ammonia is NH3, so that'll mean there's more NH3 formed because there's less moles of gas there.
Okay, that's fine. Next one is in the manufacture of sulfuric acid. You have this. He's saying the reaction usually happens at 400 degrees centigrade and 1 atmosphere pressure,
Okay.
and it is decided to change the pressure to 20 atmosphere. So he's basically the industry is increasing the pressure, like from
Okay. Okay.
1 atmosphere.
That I think it'll be two because there's more pressure, so it serves the side with less moles of gas, and that is 2SO3.
So there's going to be increased percentage of sulfur trioxide, right?
Yeah.
Well, that's fine. But what about one?
You'll also do that because you gotta maintain something which is not normal, so obviously that require energy, which costs money.
Okay, so that's one of the drawbacks of using a higher pressure. Uh,
Okay.
what about three?
Um, the rate of backward reaction actually does not increase because it just increases the forward reaction
I said, remember when you talk about equilibrium, you're basically talking about the relative rate. The forward is faster
slower. So compared to the backwards.
compared to the backward, right?
Yeah.
But the third statement is not actually about equilibrium. It's talking about rate. What happens when you increase pressure?
If the rate slows down, the rate decreases.
Why? If you increase pressure, you're compressing, right? The particles are closer together.
Yeah.
The
Yeah.
particles are closer together,
Hmm.
so they're going to bump into each other more.
Okay. And then
So you get a faster reaction.
okay.
Like if you compress it,
Hmm.
this thing,
Yeah,
particles will be
you're forcing them to go together. So you okay.
no, but you're forcing them to be closer to each other, right?
Yeah.
So they're going to bump into each other more,
Okay.
and there's going to be a lot faster reaction, right?
Yeah. Okay.
So now, so the rate of both reactions would increase.
Okay.
Okay, just remember that with pressure, the rate of reaction increases.
Okay.
The forward increases more in this case, though.
Okay.
So what would increase the equilibrium yield of methanol in the process? Methanol is this one.
Um. Okay. Adding an excess of steam. What will I do? Increasing the pressure so favor side with less. Increasing the pressure.
Okay, fine. So there's 2 moles and there's 4 moles on that side.
Hmm.
Uh, Again, this is about the Haber process, which is the exothermic reaction that we just discussed. N2 plus 3H2
Hmm.
in equilibrium with 2NH3. So, what happens at higher temperatures? And
Um,
it's an exothermic reaction.
okay, so exothermic prefers lower temperatures, so the rate of so the equilibrium will shift to the left because it won't like it when the temperature goes down. So
Okay.
when the temperature goes up.
Is the first statement correct?
No.
The yield goes
Wait,
down.
the yield does go down. Yeah,
It's going to go backward, right?
yeah.
But the rate of production of ammonia, is that going to be faster or slower?
It's gonna be faster because
Okay.
they bump into each other more because they have more energy.
Okay. So remember, just rate has nothing to do with equilibrium. Okay? Rate is separate.
Okay, okay,
Uh, so you're getting lesser ammonia, but you're getting
mm,
it at a faster rate.
okay,
So I mean, instead of getting 100% ammonia, but if it takes 10 days, that's pointless. But
okay,
if you get 10% ammonia and
mhm,
you get it in 5 seconds, that's a lot more.
okay, okay, yeah,
So the first statement is correct. At higher pressure, the yield goes down, but the rate of production of ammonia is faster.
okay.
Is that correct or not?
The second one, the yield goes down with the rate of production. Oh, a higher pressure, a higher pressure is the yield goes up, so it can be right because it's got less moles of gas on the right, and it prefers one with less the equilibrium, so it
At
shifts
higher
it right.
pressure,
At higher pressures, the yield will go up because it prefers the side with less moles of gas.
because that's incorrect, right?
Hmm. The
What about
third one is incorrect as well because the yield stays the same,
yeah?
but
Because
yes, it's
both
the production is faster.
both both forward and backward they increase equally. Okay,
Yeah.
now this reaction. What are possible reasons why the forward reaction is more likely to occur at higher temperatures?
Um, at lower temperature, the position of equilibrium lies too far to the left.
Okay, that makes sense.
Yeah, and then uh, the energy of activation is high. That could be possibility.
That's why you need a higher temperature. That makes sense.
Yeah, yeah.
Okay. Uh, and the first one is definitely incorrect because he's saying hydrogen and carbon monoxide do not react at high temperatures. Things
But then what's
actually
the point?
things actually
wh-
tend to react more at high temperatures.
Okay,
I mean, it's the low temperature where they usually don't react because they don't get the activation energy because
yeah,
because
okay.
because you have to break the old bonds first.
What's the real activation energy and binding energy? Is activation just the energy that is needed to overcome the binding energy?
I don't know what you're talking about when you're saying binding energy. Binding energy is it's
Is the
im-
thing that holds the atom together, right?
I think that's physics.
Yeah. Oh,
That's
but
that's
it's
more
unrelated.
that's more related to the nucleus.
Oh, okay. Oh, yeah, yeah. Because you don't need to do anything with the nucleus. Oh, yeah, okay.
Okay, the energy it's energy required to break a nucleus into its constituent proton and neutrons. So we're not
Okay.
that's physics. We're not doing that. That's
Yeah.
radioactivity.
Okay.
As the next one, you have this reaction. What does it say? Which one is the correct statement?
The increase in acid concentration. Okay. So if you increase the amount of acid, then it'll go to the right more. So it's right. The first one's right.
I think that's the one that's right. Um Ammonia is produced commercially by the Haber process, in which so which statement? I forget. We haven't done the commercial process yet. Forget this. Let's talk about this one. So there's phosphorus. I mean, these are the gases that are present.
Mm,
PCl5
Hmm.
He's saying phosphorus pentachloride is introduced into an empty gas syringe which has a movable, tightly fitting plunger.
Okay.
Movable means that you can sort of increase the pressure, decrease the pressure, right?
Okay.
The gas is allowed to expand until equilibrium is reached at a temperature at which the phosphorus pentachloride partially dissociates.
Okay.
PCl5 is in equilibrium with PCl3 and Cl2.
Okay.
So which statements are correct?
Um. When the planetary pushing the equilibrium, the I just to produce more. Okay. So the second one is right
The,
because
when the
there's
plunger
less
is
moles
pushed, it
because
just produces.
the more pressure, so it prefers the side with less moles,
Yeah,
and the side on the left has got less moles.
yeah.
And then when you get the gas emission, you just gas emission. So the third one is wrong. Wait,
Why is the third one wrong?
wait, I don't think it's wrong. Wait, I'm not sure if it's wrong. The volume of gas in a string at equilibrium will be greater if no. Yeah, that's correct. Number three is correct because you
Because
plunge it
if
down and then the
dissociation
volume
happens,
decreases. Yeah,
the
volume
volume
decreases.
volume of the
Yeah,
syringe would be greater. Like
really?
one molecule dissociates to
Oh,
produce.
it's allowed to expand. Oh, okay. Okay, no, see, okay, okay. So then that's fine. Okay. So he's right.
And you're going to get more gas, right, if dissociation happens.
Yeah.
And the next one. First one, what's wrong with the first one? The equilibrium pressure inside the syringe would be greater than the atmospheric pressure.
Um, want to be the same?
It's going to be the same because if the pressure inside is greater, then the plunger would be pushed out.
Okay.
So since the plunger is not moving, because I think he did state somewhere, well, the gas is allowed to expand. Eventually, when equilibrium is reached, it would stop expanding, right? So the plunger would remain fixed
Still okay. Okay.
because the pressure inside the gas and the atmospheric pressure that's outside, that would remain, that would sort of balance out.
Okay.
I said let's talk about this one. Forget the shape.
Okay.
Uh, what you have to, I mean, this is an equilibrium reaction. Think of this as
Hmm.
equilibrium. What you have to tell is whether this reaction is endothermic or exothermic.
Okay. Okay. So it prefers higher temperatures. So that means endothermic.
Okay, that's fine. This one, the reaction is being carried out under these conditions. What would be the consequence of carrying out the reaction at the same temperature but at a pressure of 200 atmosphere? So he's
Okay.
tripling
So
the
the
pressure.
the 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 mm, so the maximum yield at equilibrium two and three.
What about one? You're increasing the pressure three
Oh
times.
yeah, I saw. So one, two, and three. Sorry. Yeah.
Yield would increase and the reaction would obviously be faster. Um,
Yeah.
which change of conditions will cause the purple color of the equilibrium mixture to become paler?
Um.
Where do you want the equilibrium to shift to make it paler?
To the right.
Yeah.
Wait. Oh. The propeller. Yeah. Okay. So if any change in pressure will not make a difference because they're the same,
Okay.
and so it prefers to go to the right. So if you increase the temperature, it'll go more to the right more. So it's gonna be D.
Let's see. Which statement about this reaction is incorrect?
Okay. So to increase pressure gives higher yield of SO3. The first one is wrong. Oh no, no, so never mind. That's not wrong. That's right.
That first one is right.
Okay, and then so it prefers to have a low temperature. So if you go to high, then it goes lower. So B, I think. Yeah, B. But it prefers to have a low temperature, and if you give a high
Yeah.
temperature, then it goes lower. So then it goes right.
See, that's fine. Uh, Sulfur trioxide is manufactured from sulfur dioxide and oxygen using the Carnot process.
What's the con? Okay, never mind.
I mean, forget Casey. We don't know what Casey is. Uh, what happens when the pressure of the system is increased?
Okay, so the pressure is increased, so they're gonna be the rate of reaction will increase, and the position of the equilibrium D.
B?
D.
TKD is fine. I think we did this. Forget this. So, what are necessary properties of dynamic equilibrium?
Um. So three
Okay,
and two.
okay.
Uh, if it was one, I'm not sure about one though.
They're not going to have equal. I mean,
Yeah,
they can have equal amounts.
they don't have to have them.
Yeah, but that's not a necessary condition because maybe the equilibrium has shifted to the right and more products are formed,
Okay,
and maybe the equilibrium has shifted to the left and more reactants are formed.
okay.
So that's not always true. Okay, let's have this question now. One second. Take this one. So you're given what is he saying? He's saying that is this reaction.
Mm,
The synthesis of methanol, this one, is carried
yeah.
out at about 500 Kelvin with a pressure between 40 and 100 atmospheres.
Okay,
And using a catalyst, the use of such conditions will affect both the rate and the equilibrium yield. In the space below,
okay,
explain the effects of higher temperature, higher pressure, and use of catalyst on the equilibrium yield of methanol.
okay. They have a positive enthalpy.
Hmm. Let me check. Why is that not given the question? Maybe it was given the question. Uh, but let me just. I can copy that. Just give me one second. Let me Google this. It must be given. So the synthesis of what's the statement? Synthesis of
Methanol.
methanol is carried out at about 500 kelvins.
No, it's an exothermic reaction currently.
Yeah, yeah, this one.
Wait, so, okay.
It's going to be. It's probably an exothermic reaction. Let me just. I think it's from this paper. This one? No. I see you're supposed to calculate the enthalpy of reaction, and then they went to this part. We can. I mean, you're supposed to calculate this. Forget this.
How you gonna calculate it? Okay.
Forget the calculation. Just where's your question? And then let's assume it's exothermic.
Okay. So if you have high temperature, then it will increase the yield, equilibrium yield of methanol, because the equilibrium will shift to the right because it prefers being at a, oh wait, no, exothermic.
I'm saying exothermic. Yeah.
Okay, so opposite then. So if you have a high temperature, then the rate of reaction will decrease, but it prefers to have a lower temperature. And if you increase the higher temperature, then it basically won't like it, and then it will not do the reaction as readily as before.
Okay. And what about higher pressure?
With high pressure, they're gonna be wait, can you please go up? I want to see the thing. HCC.
One second.
Okay, so the rate of uh, so the equilibrium yield will increase,
Sure.
and the rate be,
And
and the rate of reaction
what you're
will
no,
increase as well.
it's not talking about the rate. I think
Okay.
only the equilibrium yield. And you're going to say that it's going to
Okay.
favor the less gas mole side.
Yeah, yeah, because it prefers having less customers,
And what
and
would a catalyst do?
that will not affect the yield at all because it makes it increases the rate of reaction both ways. So overall, there's no net change in the yield,
Okay.
just in the rate.
So then you have this reaction, and they're saying by looking at these values, uh, can you guess? You're saying different amounts of per placed in a vessel. The equilibrium concentration of the three gases at each temperature are given in the table below. So, what do you think? Is the forward reaction endothermic or exothermic? Explain your answer.
Okay. I don't get what this table is showing.
Hmm?
I don't get what it's showing.
So you're given the quantities, right?
Hmm.
Now, look at the product.
Okay.
Like at 230,
Okay.
you're getting more products, right?
Hmm. Yeah. Okay.
Compared to the
But
reaction.
yeah, competitor. Yeah.
I mean, this is minus 3, that's minus 2. So you're getting more products, right?
Yeah.
But what about 465? You're getting minus 4, and that's
Hmm.
also minus 4.
Hmm.
So that means you're getting less products, right?
Yeah.
So is the forward endo or exo?
So you get less. So you see, you get less process at a higher temperature.
Mhm.
So which means it does not like to be a high temperature. So you're gonna have negative enthalpy. So it's gonna be exothermic.
Wait, higher temperature. So it's going to be exothermic. Yeah, that's fine. That's fine. Do we have any other question? No, we've run out of questions. So, ठीक है, if we're done with, I think we're done with the Shatler principle.
Okay.
ठीक है. So let's we'll do Haber and contract process after this. It's going to be related
Okay.
to the same thing. ठीक है.
Okay. So see you on Monday at. Sorry. See you on Wednesday at quarter past.
Yep, quarter past.
You see you on the office.
Okay, take care. Allah Hafiz.
Office.